Here we have a SAT math question. There is a figure given over here. In the figure above, triangle ABC and triangle DBE are right triangles. If AC equals to 12, BC equals to 15, and DE equals to 8, what is the length of BE? Okay, here we have two right triangles in the figure above, ABC and DBE, and the length of the side AC is 12, and the length of the side BC over here is 15, and the length of the line segment DE over here it's 8, and we have to find the length of the line segment BE. Okay, now let me consider the two right triangles ABC and DBE. In the first right triangle ABC, we have right angle at the vertex C. Okay, now let me write the vertex where we have right angle, the first triangle ABC, that is C. And now let me consider the second triangle, second right triangle DBE. In the second right triangle, we have right angle at the vertex C. Okay, let me write it over here. And B is a common vertex for both the triangles ABC and DBE. Now let me write the common vertex for both the triangles. Okay, now so the two angles of the triangle ABC, I mean the angle measure C and angle measure B, are congruent to the two angle measures of the right triangle DBE, that is angle measure E and angle measure B. So whenever two angle measures of one triangle are congruent to two angle measures of another triangle, then the two triangles are said to be similar by angle similarity postulate. So the two triangles, the right triangle ABC and right triangle DBE are similar. So because the angle measure C and angle measure E are equal, and also B is a common angle. By angle similarity postulate, the two triangles are similar. Okay, now let me write the third vertex for the triangle right triangle ABC. Already I have written the vertices C and B. The third vertex is A. And for this right triangle DBE, already I have written the vertices E and B. The third vertex is D. So now the two triangles are similar. Okay, using the triangle similarity concept, I am going to find the length of BE. Okay, since my aim is to get the length of BE, so first let me take the side BE from the second right triangle over here. And what is the corresponding side in the first triangle over here? So here, just consider the side BE in the second triangle. I have considered the second alphabet, the first alphabet. Now in this triangle, we have to consider the alphabets at the same position. That is second alphabet, first alphabet, then we get the side BC. Okay, now I have to take another side in the triangle EBD, that is in the second right triangle DBE. So in the second right triangle DBE, I know the length of the side DE. So now let me take the side DE in the second right triangle and the corresponding side in the first triangle. So I have to consider the alphabets at the same position. Here we have D at the third position, A at the first position. Now consider the letters at the same position. A, the third position, C at the first position. Then we get AC. Okay, so B is unknown. I do not know for this B only I have to find the length. So for BC, I know the length it's 15. Let me plug in 15 for BC. And for D, I know the length it's 8. And for AC, I know the length it's 12. Okay, now I have to solve for B in this one. So for that, I have to multiply both sides by 15 to get up the denominator 15 over here. Let me multiply both sides by 15. This 15 and 15 will cancel out. And here, both 8 and 12 are the multiples of 4. So we can divide both numerator and 8 and denominator 12 by 4. 4 goes into 8 twice and 4 goes into 12 3 times. And 3 goes into 3 1 times and 3 goes into 15 5 times. Now we have B on the left side. On the right side we have 2 times 5 is 10. 10 divided by 1 is still 10. So the length of B is 10 units. We find 10 in option D. So the correct answer choice for this question is option D.